This video is going to be a quick review of common logarithms from lesson 8-3. So what is common logarithms? Common logarithms use base 10, which is what our number system would be using. So an example, we're going to take log base 10 of 8 and we're going to round it to the nearest 10,000th. But we're going to use our calculator for this. Now you'll notice when it says log of 8, they don't put the base in there because common logs aren't going to put base 10 in there, or at least write it down there, but just know that if you don't see the base there for a logarithm, it means base 10. So on our calculator, we're going to type in log 8. 10,000th place means 4 decimal places, so that'll be 0.9031. So x is equal to about 0.9031. And for this next one, log of 101, grab our calculator again, log of 101, and parentheses, 4 decimal places, this would be 2.0043. Now, how does it work with a word problem? Here it says the loudness L in decibels of a sound is L equaling 10 times log of I divided by M, where I is the intensity of the sound and M is the minimum intensity of sound detectable by the human ear. If M equals 1 and a theater has movies playing at 95 decibels, what is the intensity of the sound as related to the minimum intensity that we can hear? Write your answer in scientific notation. So I'm going to substitute some numbers in for L and for M, and I'm going to flip this around to make it a little bit easier to solve. So I have 10 times, and I'm going to separate the log of I divided by M as a subtraction. So when I expand it for division, I write it as a subtraction. So this would be log of I minus log, and M is 1, so log of 1. And this is going to equal 95 because our loudness in decibels is 95. Now to get the parentheses by itself, I'm going to divide everything by 10. And that gives us log of I. Now log of 1 means base 10 raised to what power gives me 1? Well, I know that anything raised to the 0 power is 1, so that means log of 1 would equal 0. So if this is 0, I don't need to put minus 0 down. So now all I have left is log of I on this side, and 95 divided by 10 is 9.5. Now from this point, I can use exponentials. So remember, this is base 10, so 10 to the 9.5 power is going to give us our intensity. So at 10 to the 9.5, we grab our calculator. So we have 10 raised to the 9.5 power. That gives us a really large number. So this would be 3,162,277,660. So if we're going to round it to the nearest tenth in scientific notation, this will be 3.2 times 10 to the 9th. Next, a search engine ranks pages by their popularity by using a scale, where a site is given a rank R based on its visits per day, V. The rank is related to the number of visits by the equation R equals log of V plus 2. If a site has a rank of 5.5, then approximately how many visits per day does it get? So we are solving for V, with our R, which is our rank, is 5.5. So I'm going to substitute those in. So right now I have log of V plus 2 equals 5.5. Now to get log of V by itself, I'm going to subtract 2 on both sides. And I'm left with log of v equaling 3.5. And just like the last one, I'm going to rewrite this as an exponential. So I have 10 raised to the 3.5 power. That's going to give us our v for the visits. And here we're going to run to the nearest visits. So I have 10 raised to the 3.5 power. And this is going to give us about 3,162 visits. Next is our solving of exponential equations by using the logarithms. Now, when we have an exponential, we're going to use the properties of logarithms to help us simplify it. So this first one here, since I have an exponent here, I'm going to use the power product rule of exponents. So that means I'm going to put this out in front, and this will be x times, and then I'm going to use common log of 11 equals, if I did the log of one side, I have to do the log of the other side, so there'd be a log of 101. Now I can get x by itself by dividing by a log of 11 on both sides. And x is going to give us, grab our calculator again, here we got to do a log of 101. And it's important that you hit the end parentheses first before you hit the division sign, and then log of 11. And to the nearest 10,000th place, this will be 1.9247, so 9247. 1.9247. Next, solve this one. So I have my exponent that goes out in front, so it would be x times log of 2 equaling the log of 15. To get x by itself, I'm going to divide by the log of 2. And x is going to give us, just going to do a second enter and just change a few of these. So log of 15 divided by the log of 2. This is going to give us 3.9069, so 9069. And our last one here we have an extra step because we have a number with our exponent, so we put that out in front. So this would be 2x times the log of 11 equaling log of 9. To get 2x by itself, we're going to divide by log of 11. And so that's going to give us 2x equaling log of 9 divided by log of 11. And to get x by itself, we're going to divide this by 2, which is the same as multiplying by 1/2. So on our calculator, I'm going to put in parentheses log 9 end parentheses divided by log of 11 end parentheses end parentheses. So I'm going to take all that and I'm going to divide that by 2. And that gives us 0.4582. So 4582. So what we were doing helps us with our next part, which would be the change of base formula. The change of base formula allows you to write equivalent logarithmic expressions that have different bases. And that's important because sometimes our calculators can't do the change of base, so we have to use the change of base formula like I was just showing you before with it. So for all positive numbers a, b, and n, where a cannot be 1 and b, the base, can't be 1, log base a of n can be rewritten with the formula of log base b of n divided by log base b of a. B is just going to represent the common logarithm, so base 10. So how does that look with numbers? If I'm trying to solve log base 8 of 17, I would just do log of 17 divided by log of 8. So the log of the argument divided by the log of the original base. So an example. Here we want to evaluate this with common logarithms. So this would be log of 11 divided by a log of 2 to the nearest 10,000th place. So we have log of 11 end parentheses divided by the log of 2 end parentheses, and we get 3.4594, so 4594. This next one, we would have log of 52 divided by the log of 6. Grab our calculators, so log of 52 end parentheses divided by the log of 6 end parentheses. That gives us 2.2052. And with a word problem, here it says the function f of x equals -3 plus 16 log base 12 of x gives the estimated number of Canadian geese in a state park, where x is the number of years since 2010 and f of x is the population in hundreds. In hundreds is important because when we plug our number in, we have to remember to convert that to in hundreds. It says write a function that represents a situation and is written in terms of common logarithms. In what year will the estimated Canadian goose population at the state park exceeds 1,500 geese? Now, I'm not going to write this one completely in common logarithms because there is actually a quicker way of doing it, and I'm going to show you the quicker way. So, we need to solve for x. F of x is the population of geese in hundreds. Now, if they're saying 1,500 geese, how many hundreds is 1,500? That would be 15 hundreds. So I'm going to put 15 in for f of x. But I'm going to just flip these around first. So it's going to be -3 plus 16 times log 12 of x equaling 15. Now to get our logarithm by itself, I'm going to add 3 to both sides. And this is going to give us 16 log of 12 of x equaling 18. To get our logarithm by itself, we divide by 16. And this is going to give us log base 12 of x equaling 9/8. Now what they want us to do with common logarithms is rewrite the left-hand side as log of x divided by the log of 12 equaling 9/8. What I'm going to do, the quicker way of solving for x is I'm going to do base 12 raised to the 9/8 power, and that's going to give us our x. Otherwise, this other side, you would just have to multiply by a log of 12 on both sides, and then simplify from there. But again, writing it as an exponential is going to make it a lot quicker. So if I grab my calculator, I have 12 raised to the 9/8. That's going to give us about 16 years. Now let's just say I did it the other way. So I would have 9/8 times log of 12. I'm going to get that, and then if I exponentiate that, I would have to take 10 raised to that power, and you'll still get that same answer of 16.3711. So I'm just going to keep what I have first time. So x is going to be about 16 years. So in what year they're asking you? So since 2010, I would have 2010 plus 16 would give us about the year 2026. And our last example. The revenue of a company is R equaling 227 plus 44 log base 5 of x, where R is the annual revenue of a company in thousands. So there's our key phrase here, in thousands. And x is the amount spent on advertising in thousands. Use a graphing calculator to determine the amount spent on advertising if the revenue for the company is $325,000, round to the nearest dollar. So if this is in 325 thousandths, that means I have 325 of them because that's in thousands. So my R is going to be 325. So I have 225 or 227 plus 44 log base 5 of x is going to equal 325. To get the logarithm by itself, I'm going to subtract 227. So I grab our calculator. We got 325 minus 227. This is going to give us 98. So we got 44 log base 5 of x equaling 98. We're going to divide by 44. Divide by 44 gives us 2.227272 and so forth. Now we have log base 5 of x is going to equal our answer, which we had 2.2272. So I'm going to make that 2273. Now if I take base 5, raise that to that power and gives us our x. Now since I already have it all in my calculator, I'm going to do 5 raised to and then hit second answer. This is going to give us about 36.0409. So we'll just count that as 0.041. So if that's in thousands, I would have to multiply this by 1,000. So that's going to give us 36,000 to the nearest dollar would be 41. So $36,041. So as a quick review on using common logarithms and change of base formula.